342 kilogram rocket, 292 kilograms of which is fuel. Burns all of its fuel in 38 seconds with an exhaust velocity of 880. What are the initial and final accelerations of it? Okay, so the first thing we want to do is figure out the initial mass, and that's going to be this guy, right? So 324. Right, the final mass is going to be, we got to burn the fuel, right? So it's going to be 324 minus 292, okay? I think that's going to be 32, but I'm going to do careful work here. So 324 minus 292, 32. So the final mass, as the last molecule of propellant leaves the exhaust, is going to be 32, okay? Assuming that the thrust doesn't drop before it does that, right? Assuming the engines don't actually warm up like they actually do. This is a simplified version, okay? We can do this. So that is our first step, right? Figure out the initial and final mass. Okay, the second thing to do is to figure out the thrust of the rocket, okay? So we're going to go force times time is mass delta V, okay? Now our delta V is 880, so that's easy, right? Now we got to figure out the mass and the time. And the question is, what mass do we use? There's so many masses. There's this, there's this, there's this, right? You want to use the fuel mass. This is the mass of the fuel, okay? Use the fuel mass and the time to burn that fuel. If you do that, you'll always get this right. So the time is 38 seconds to burn that fuel, okay? So this type of problem, they tell you how long it takes to burn that fuel. That's great. Use all the fuel. This has to be the fuel and all of the time. In the ones where they say kilograms and in per second, use the kilograms and 1 second. Okay. All right. So 292 times 880 divided by 38 is 6762.105. Newtons. It's newtons of force. All right, and now we've got the tricky job of figuring out the initial and final accelerations. Now in the initial, we've got 324 kilograms of rocket. In the final, we have only 32 kilograms. Okay, so initially this rocket's kind of a chorker, right? Okay, the force upward is easy, right? The force upward is going to be our 6,762.105 up, and the force down is going to be 324 times 9.8. Let's figure this out. That's the force of gravity, right? 324 times 9.8 is 3175. This force is 3175.2 newtons. And now we're set. Now we can just do Newton's second law, right? So this force is up, so 6762.1 is up. This force is down. And then that equals our mass, which is 324 times A. Now we're set. So I'm going to go this guy. I'm just going to use up arrow on my calculator because I'm far too lazy to type all those numbers in. So that guy, 6762 minus 3175. And I'm getting 3586.9. Okay, and then I'm going to divide by 324. And I get 11.07 or 11.1. So the initial acceleration is 11.07 meters per second squared. And we'd round that to about 11.1. Okay. Okay. Now in the end, we've got a similar situation, but some things are different. So let's figure this out. We still have this upward force of 6,762.1. Our downward force, though, is much less. It's going to be 32, the mass, right, times 9.8. So 32 times 9.8 is only 313.6. So now we've got the same force up, a measly 313.6 newtons down. We're going to set up Newton's second law. So 6762.1 minus the new weight, right? 313.6. That equals 32 times A, right? So we got a new mass, right? The mass is 32 now. Okay, so we can do this. The 6, let's find that number. There it is. Okay, minus the 313.6. This is, by the way, 6448.5 when I do this, right? And then I'm going to divide by 32. And I get 201.5. And there's a little change after that 5, so you would round that up to 202 meters per second. Okay? Hoo-hoo!